Welcome to another exciting episode right here on IT Pro TV. I'm your host, Ronnie Wong, and today we're going to be taking a look at, well, PMP, Project Management Professional. And we're specifically going to be diving into the critical path method. And who else better to help us than Mr. Don Pizzette? How's it going, Don?
It is going great, Ronnie. Thanks for having me on the show. And I'm excited to be kicking off our Formulas in Action series, right? We're going to be taking a look at a lot of the formulas that we need to know for the PMP exam and just running through some examples, how to use them, how to get really comfortable with them, because on the exam, you shouldn't dread the formula questions. You should really appreciate them and go, boy, that's going to be an easy one. All I have to do is a little math. And that's usually what it boils down to. So in this episode, we're going to tackle the critical path method. We'll get a chance to see a great example. We'll run through it and do the forward pass, the backwards pass, all the different things that we talked about earlier in the series. And not only are we calculating critical path, we're also going to be calculating things like float and free float and getting a chance to see those also, all just right here wrapped up into one nice big example.
All right, so Don, before we get started, it's probably best if you remind us, because I know it's like me, you may have actually gone through this several times in your head and you've seen the actual little template that's there, but a lot of times we forget, so this is a good place to remind us about this.
Yeah, you know, on the exam, what they're going to do is, well, there's a few different ways they can do it on the exam. We'll see in some of the examples I give, but they're normally going to show you a project schedule network diagram, right, a PSND. And if you don't remember what a project schedule network diagram looks like, it looks like what I've got here on my laptop. It's a bunch of boxes that are kind of arranged, and I've added a little bit to it, right? In the normal template, you don't have float at the bottom of a box, but you do have the ES, EF, LS, LF, and a couple of other bits of data jammed in there. So let's talk a little bit about what all that is, right? So when you're looking at one of these boxes, it may or may not have float. Like I said, you know, that may just not be there. It may look like that, right? And if it looks like this, what you've got is early start, early finish, late start, late finish. There are four values that you don't necessarily have when you launch a project, right? You have to determine what those values are, and that's really what critical path method does. In fact, when you start a project, there's normally only two pieces of data that you have: the task name and the duration. That's what D is right here, duration. So the duration is how long that task is going to take, and then we've got to arrange all those tasks together to figure out exactly how long this is all going to take, right? You know, when is my project going to finish? And where do I have little gaps of space where I can slow down or speed up if need be, all right? And that whole slowing down and speeding up part, that's where float comes in. That's why I normally add float onto the bottom of this so that I can keep track of it, right? Now, when it comes to critical path method, the bulk of the math that we're doing is really just addition, simple addition, so not really crazy formulas. And the only real formula we need to remember is the formula for calculating float. And float is simply late start minus early start, right? Early start is the earliest this task can start. You know, we can't start before this particular point in time. And early finish is if we're running perfectly on schedule, what's the earliest we can finish, right? Late start is how late can we start and still finish our project on schedule, right? Without going over our schedule. So late start's pretty important, and then late finish would be the latest we could finish, and again, still have our project finish on schedule. If there's no difference between these, right? If late start minus early start is 0, or late finish minus early finish is 0, that means there's no difference, right? They're the same value, and you've got no float, 0 flexibility. But if there's a difference between these numbers, then you're going to have some time that you could fall behind if you needed to, that you could take resources off of one task and assign to another to make up your schedule. So that's important that we recognize where that is, and critical path method will let us do that. So we calculate our critical path and we calculate our float really all at the same time using the same techniques, and that's what we're going to run through in this example. And so the example that I've got worked up is this topology right here. And I've got the basic elements of what we know about a project when we kick off, right? So I've got my task names, and I just use letters, you know, so A, B, C, all the way through, what's my highest one? I. So A through I are my task names. And then I've got the durations, and I did durations in days. You could do hours, you could do weeks, depends on how long your project is, but I did mine in days. So like this is task A, and task A is going to take 1 day. Or up here I've got task C, and it's going to take 4 days, right? That's all the information I have. This is very indicative of what you would get out of like a work breakdown structure. That's all it's going to have is task to do, how long it's going to take, all right? It's up to us to then calculate everything else. And for the exam, you need to know how to calculate all of these other values. Now, in our first two examples, we're going to run through calculating the whole thing. On the exam, they're not going to have you do that. On the exam, they're normally going to have you just calculate out one of these squares, and usually it's one particular value. So for example, you might see a square like this one, and everything else is filled in, but this one has blanks. And it says, what would be the early finish of task C? And you've got multiple choice answers with just numbers in them, and you pick the appropriate one. So you just need to calculate a single value. But working through a whole example like this will help you better understand it. So we're going to do the whole path first, and then in a follow-up episode, we'll break it down more like the exam does and hit just a single area. All right, well, let's get started. The first thing we need to do with critical path method is to calculate out what's called a forward pass. We need to start from the beginning, and basically we're going to calculate all the earliest that we can do things. So assuming that everything runs great, everything runs according to plan, what is this going to look like? So we're going to calculate out the early starts and the early finishes. Now, one of the challenges that we hear from a lot, we get viewers that write in and say, Don, I'm really having a problem with this, is that a lot of us are IT guys. And so when we start counting, we always start from 0, right? and so when I have a project start, we're starting on day 0, and it's going to take 1 day and so on. But in project management, we don't start at 0, because these are actually units of time. And so we need to start them based on, for example, days. And I'm doing days. So when I say this is day 1 that this project is going to occur on, I don't actually start at 0. My early start isn't 0. My early start is 1. I'm starting on day 1. And then we continue on. The way I like to do it is think of these durations as days of the month, right? So this might be January 1st, 2016, all right? So this task is going to start and finish on January 1st. It's not going to start on day 0 and finish on day 1. That would technically be 2 days, right? So we're going to start on the 1st, and we're going to finish on the 1st. No crazy math needed there. It's a 1-day task. It starts on that day and it finishes. All right. Now, task B and E both have dependencies, and their dependency is task A. Task A has to finish before B and E can start, right? It's a finish to start relationship. And so if task A started on day 1 and finished on day 1, and it was an entire day of activity, can I get any more work done on that day? No. So anybody that follows on after that is going to have to start on day 2. So now I'm in day 2. So when I look at task B and task E, the earliest they can start is on day 2, right? This one took up day 1, and so now these guys are going to start on day 2, all right? So I fill both of those in. Now, task B is a 2-day activity, all right? And here's where things really get dangerous, right? As dangerous as it gets. Because the temptation is to say, all right, I'm on day 2, let me add 2, we finish on day 4, okay? But that's just traditional math. That's normal numbers. That's not what we're doing here. We're thinking of days. So I took all of day 2, January 2nd, but this is a 2-day activity, so I also need January 3rd. So this one is going to finish on January 3rd. I find that thinking of them as dates really helps me to make sure I get these numbers right. So January 2nd, January 3rd, there's my 2 days for task B. Task E is only 1 day, though. So it starts on January 2nd, it finishes on January 2nd. All right, so I fill those values in. And now I continue on. Now, this particular project has 2 very obvious paths. I've got B, C, D, and then I've got E, F, G, H, right? So a path across the top, path across the bottom. If all I'm trying to do is find my critical path, on a simple one like this, I really wouldn't even bother with the forward and backwards passes. I would just add up the durations, right? Whichever path has the longest duration, that's going to be the one that wins. That's going to be our critical path. So if the question is just asking me which of these is the critical path, well, I've got 2, 4, 3, so that's 9 across the top. Is that good math? Yeah, yep. So 9 days across the top. And then down here, I've got 1, 5, 4, and 1, so I've got 11 days across the bottom. 9 days across the top, 11 days across the bottom. The bottom is my critical path, right? It's longer. But they might not all be simple like this one. And we'll see in my next example. It's a little more complex, and so just adding those up doesn't necessarily work. But if I'm also looking for things like float, or if they're asking me for the early start of a particular task, it doesn't matter to me which one is the critical path. I need to find that particular data. So that's why you need to be comfortable with all the different methods of calculating this out. All right, so let's continue on, and I'm just going to focus on the top path for right now and fill this out, right? So we have task B finishing on day 3. which means the next task can't start before day 4, right? This one finished on the 3rd, this one can start on the 4th, and it's a 4-day activity. So it's going to take the 4th, the 5th, the 6th, and the 7th, and so the earliest it can finish is on the 7th. All right. Continuing on with D, the earliest it can start is on the 8th, right? So it's going to start on the 8th of the month, and then it's a 3-day activity, so we'll need the 8th, the 9th, and the 10th, and we'll finish right there on the 10th. Okay. So the top path, BCD, will finish January 10th. All right, I'm just using January 10th as an example here. It could be whatever day your particular project is assigned. And boy, there's another complexity. They won't hit you with this on the exam, but what if you have to factor weekends into this, right? If you have to factor weekends in, I might have 2 days that we can't work. And so I might start on the 8th and finish on the 12th because maybe the 9th and the 10th were Saturday and Sunday. Right? So that's when things really start to get a little bit messy. But fortunately, your other path will be doing the exact same thing, and so you'll have that same delay for both. But that's where project management software really comes in handy. All right, so I've got that path kind of laid out right there. Now I'm going to go back down to the bottom and continue on with this one. So task E is finishing on day 2. Task F can start on day 3 if it wants, and it's a 5-day activity, so it will finish on day 7. Then task G, we're going to bump that one up to the 8th. It can start on January 8th, and it's a 4-day activity. And so that one's going to finish on, let's see, that would be the 11th. There we go. All right, so just if you need help coming up with these numbers, you can count on your fingers if it's a small number, right? So I can say so I can go the 8th, 9th, 10th, 11th, right? That's one way to do it. Or what I'm actually doing in my head is I go ahead and do 8 plus 4, and then I just subtract 1. Right? I do 8 plus 4, and that gives me 12, and I subtract 1 because I have to count the 8th, right? So that's a little shortcut that I use that makes it a little easier, and it works better with bigger numbers, right? What if this was, I start on the 8th, and it's a 15-day duration? Well, you can't really use your fingers anymore if it's a 15-day duration, but you can do 8 plus 15 and get 23, and then subtract 1 and get 22, and so now you know it's 22, right? So that's kind of a little shortcut that I use, which would be the early start plus the duration minus 1. That's not an official PMI formula. All right, and then we move over here to this last one, task H, which only has a duration of 1. And so it can start on the 12th, and its duration is 1, so I can just finish it on the 12th also. All right, and then lastly, we get all the way down here to task I. Now, task I has a dependency, or has 2 dependencies, right? It needs task D and task H to finish before task I can start, okay? Well, if I look at task D, the earliest it can finish is on the 10th. And if I look at task H, the earliest it can finish is on the 12th. All right. So because this one can't finish until the 12th, task I can't start until the 13th. Even though this guy up here is done, we have to wait for this other one to finish too. So this one is going to be the 13th, and that means the earliest we can finish is on the 13th also. Okay. So if our project runs according to plan, if everything goes according to schedule, we're looking at a 13-day project right here. Or if these are weeks, a 13-week project, right? Or a 13-month, 13-year, whatever it is, right? But this is a 13-day project here. That's if everything runs according to plan. What if things don't run according to plan, right? What if I start to have delays? Well, hopefully I have float, and the float will eat that up, and then I still finish on the 13th day. So we need to do a backwards pass to find out anywhere we have float. To say, not that things necessarily went wrong, but if I need more time, where can I find it? And the whole point is to make sure that we find extra time and still finish on the 13th. So when we're filling out these charts, when we start calculating the lates, this is the latest we can finish and stay on schedule. So, still be a winner, still have a successful project. So the latest that this activity can finish
13th
would be the 13th. We want that to be the same as the early finish. In other words, the latest we can finish and still be early, right? Still finish at our best possible time. This is a 1-day duration activity, so that's going to be a 13 right there also. This final activity might be more than a day, and then these numbers would be a little bit different, right? But in my case, it's just all 13s. Oh, lucky number 13. This would be a great project to work.
Now, Don, at this point, once we're actually here at the end result there on I, you talked about calculating float. Is that important to calculate right here at the very end?
Well, It is. Not so much here, right? When you're on the last activity, you never have float, right? The first and the last activity, you don't have float. But where it can be a challenge is not every project rounds off into one nice task like this. You might have a project that ends in 4 different tasks. It's unfortunate, but it happens. And in that case, you might need to calculate float on those, right? So don't just assume you don't need it. But when they round the project off to a single point like this, then there's never float on the last activity, or there's never float on the first activity, because those are the beginning and the end. But if you have more than one endpoint, it is important.
Okay.
All right, now I'm going to leave float off for right now, because we'll calculate it in a minute, but it's pretty straightforward. Now I need to go backwards and say, all right, I need this activity to finish on the 13th if I want this project to be on schedule. So what can everybody else do? Well, if I want this one to start on the 13th, that means I need the predecessors to finish on the 12th. They've got to be done on the 12th in order for this guy to start on the 13th. And so for the late finishes, task H needs to be done by the 12th. Otherwise, this guy can't start on the 13th. And same thing up here for D. D needs a late finish. The latest it can finish is the 12th in order for this next activity to start on the 13th, right? So again, thinking about calendar dates, this guy's the 13th. This other guy needs to finish on the 12th to make that room. And now we just start going backwards, right? Backwards, subtracting our duration instead of adding our duration. So if we do the top path here, if this one has the latest it can finish is the 12th, and it's a 3-day duration, then the latest it can start is the 10th, right? We can do the 10th, 11th, 12th, right? 3 days, that's what it needs. And if it starts on the 10th, it can finish on the 12th, and we're fine. The last task can still start on the 13th. If I want this one to finish or to start on the 10th, task C needs to finish on the 9th. And if it's a 4-day activity, well, we've got the 5th, 6th, 7th, 8th. Oop, well, I just made my own mistake right there. Not the 5th, right? So this would be the 6th, 7th, 8th, and 9th. I would need it to start by the 6th, right? So it's got to start by the 6th in order to finish by the 9th, which would allow task D to start on the 10th. And just continuing backwards, this one's going to have a late start, or a late finish of 5, right? It's got to finish on the 5th, so the next task can start on the 6th. And it's a 2-day activity, so the latest it can start is the 4th, so that it'll finish on the 5th, right? So punching those in and just thinking these as calendar days definitely makes a big difference. All right, now let's go take a look at that bottom path. The bottom path's a little bit longer, so it'll take a little more work. Well, I say that. This is a 1-day duration, so if I need it to finish on the 12th, it's going to have to start on the 12th. It's only 1 day. Task G, if I want task H to start on the 12th, I need task G to finish on the 11th, right? And it's a 4-day duration, so if I subtract those 4 days out, I'll get 8. And so now I've got the 8th through the 11th. And continuing that on, task F, I need it to finish on the 7th so that task G can start on the 8th. And if it's a 5-day duration, I just subtract down 5 days, and I end up on the 3rd. And if I want it to start on the 3rd, I need task E to finish on the 2nd, and it's a 1-day duration, so it'll start on the 2nd. And that brings me all the way back to my original one. Now, on the exam, don't get too excited and write this 2 right here for the late finish. We need to compare it up here with this guy too. We're thinking about the latest this one can finish and have both of these activities, B and D, run as planned. Okay? So if B, the latest it can start is 4, and E, the latest it can start is 2, I need to take that lower number, right? Because if task A were to finish on the 3rd, task E just missed its late start, right? So I have to pick the lowest number. I can't delay that one. So if this one's going to have a late start of 2, then the latest this one can finish is on day 1, and the latest it can start would be day 1 because it's a duration of 1. All right. Notice how on the first task all my numbers are equal, and on the last task all your numbers are equal, right? That's what you expect to see when you have 0 float. No float, no flexibility, because this is a beginning and the end. Everywhere else in the project, if you have no float, it's normally the critical path. Not always, there's some exceptions, but it normally is the critical path. That's a task that has no flexibility. It can't start earlier, it can't start later. It has to happen at this particular time. And that's critical, because if it doesn't happen at that particular time, our project is going to be late or early, which can be just as bad sometimes. All right, so now we've got our numbers in place. Now we've calculated our early start, our late start, our early finish, our late finish. We've got all that put in place. The only thing left to do is calculate float, right? And in a simple model like this, whichever path has zero float along the whole way is our critical path. And the way we calculate out that float is we simply take, well, here, I had it on the screen earlier, right here, our late start minus our early start, right? The latest we can start, and we subtract out the earliest we can start, and if they're equal, it's going to be 0. And so we have 0 float, no flexibility. Or if it's a different number, then we have float. And it doesn't matter if you use late start, or late finish, early finish. You'll end up with the same result. So just pick one. I usually do the starts because a lot of times I might not even bother calculating out the finishes. If I'm just trying to find float, I can save time and not calculate the finishes. On the exam, you do have a timer that you're competing against, so you don't necessarily need to calculate things that you don't want.
Now, Don, that actually brings up a good point for the exam as well. Is that a recommended method that you would say, hey, when it comes down to time, let's just calculate the starts instead?
On the exam, you need to do the bare minimum to get the answer you need, right? Because at the end of the day, it's a multiple choice exam. You're graded on the answer you choose, not how you got there. So if you know a shortcut method, use it, right?
Awesome.
Remember, the first thing I said was if they're just asking me which one's the critical path and I've got a simple topology like this, I don't do a forward and reverse path. I just add up the durations. Whichever duration is the longest, there's your critical path, right? That can save a ton of time, gives you the right answer, and you move on. Just like in real life, what do? Punch all this in a Microsoft project, and it'll tell us, and you're done. You're done in minutes, right? So on the exam, we have to do it by hand. If they're asking me for early starts and late starts and things like that, I'm going to have to calculate it, right? But if they're just asking for float, just by calculating out the earlies, right, then I could figure that out. Well, actually, no, I couldn't, could I? I would need my early and my late to subtract those out, and so I am going to have to do that forward and reverse path to get that float. I'm going to have to get a little more data there. So you got to figure out what is that bare minimum of data to get in and calculate it out. Now, if they're just asking me to find the critical path and not the float, I might still have to calculate float just to be able to figure out where that critical path is. So you may end up having to do the whole process. But on the exam, they know time is of the essence, so they won't normally make you do the whole thing. All right, well, let's go in here and find out our float, and then we'll know where our critical path is, because technically I still don't know, although you can kind of see it because of the numbers. But if we start running through and calculating these out, now I know on my first task and on my last task, I know I've got 0 float, because their numbers are all equal, right? Anywhere where you see all 4 numbers are equal, then you know it's going to be that way, and not even necessarily all 4. If the late start and early start are equal, or the late finish and early finish are equal, then you know that it's going to be 0 float. So all along this bottom path, if I do 2 minus 2, I get 0. 3 minus 3, I get 0. 8 minus 8, I get 0. 11 minus 11, 12 minus 12, and so on. I'm always ending up with 0, and that's because there's no float all along the bottom. And so applying that late start minus early start, or late finish minus early finish, they're going to get me zeros across the base, right? Up here, though, are where the numbers are different, okay? So if I take my late start and I subtract my early start, 4 minus 2, that's 2, right? So I've got 2 float, right? I could have done my late finish minus my early finish, 5 minus 3, and I would have gotten 2. You get the same value. That's why it doesn't matter which one you use. You should, assuming you filled these squares in right, you should get the same value.
And that brings up a good point, right? If you're saying that it should do that, if I get different values on subtracting the earlies versus the lates,
you've got a problem.
Then I've got a problem. Yeah.
And if they're small numbers like this, it's easy enough to check. But I'll just keep running through. 6 minus 4 is 2. 9 minus 7 is 2. 10 minus 8 is 2. 12 minus 10 is 2, right? So I'm ending up with 2 across the board. And just like that, I've got my float calculated. Float's easy to calculate once you have the values. Once you have your late start and early start, or late finish, early finish. Once you've got those things in there, you can calculate those out really fast. All right. And if all they're asking me is where my critical path is, it becomes really obvious here, right? I've got float on the top path. I'm gonna say an absolute, which I shouldn't, but you never have float on a critical path, right? There are some little exceptions that can occur if you've got things like constraints in your project, but as far as PMI is concerned, you never have float in your critical path. So when I look up here at B, C, and D, because I've got float, that means these guys are not critical. These guys have a little bit of breathing room. They could still impact the project. I could still end up behind schedule because of these guys, but assuming things are running the way they're supposed to, these guys have wiggle room, and so they're not critical. But down here, E, F, G, H, I've got 0 float all the way across that line. I've got no wiggle room. Those are critical. That's my critical path. A, E, F, G, H, I. This whole bottom path, those are critical. If any one of those tasks falls behind, my project falls behind. And I go from being a 13-day project to being a 14 or 15 or 16-day project as we fall further and further behind, right? So now we've spotted that critical path and we've got it. There's one more thing we might be tasked with on the exam, and that is free float. Okay, now I calculated float, and float's the most common. That's what we worry about. Or if you use like Microsoft Project, this would be Slack. And so, we're calculating that out. On the exam, they'll always call it float. Free float's a little bit different. The definition of float is any activity that could fall behind without impacting the project, right? Talking about the project as a whole. But free float is where an activity can fall behind and not impact any other activity, right? Technically, B has 2 days of free float, or 2 days of float. So it could fall behind 2 days and my project could still finish on schedule. But if it falls behind 2 days, if it was supposed to start on the 2nd and instead it starts on the 4th, well, can task C start on the 4th? No. It now starts on the 6th, all right? And we know that's okay. It can start on the 6th and we'll still finish on time, but this one just got bumped back 2 days. What if I had contractors scheduled to be here on the 4th and this one falls behind and now I tell the contractors, hey, can you come out on the 6th instead? And they say, no, I'm sorry, we're booked for another job, right? Well, this task could have started on the 6th and I'd finish on time, but now I don't have contractors. Now I've got a problem, all right? So on the exam, float is usually what they go for, but in real life land, free float is what we normally care about. Because just because this activity can fall behind 2 days, doesn't mean we want that to happen, especially if you've got contractors scheduled on particular days, right? You can have staff issues. I might have staff assigned to work task C on the 4th and 5th, but then on the 6th and 7th, I might have them scheduled to come down here and help on task F. And now if this one falls behind, I can't have them come and help on task F, and task F falls behind, right? I might have my employees spread across that way. So free float's a little harder to calculate because basically what you have to look at is environments where you have a gap in between the finish of one task and the start of the next. See how this one finishes on the 3rd and the next one starts on the 4th? There's no gap. This one finishes on the 7th, the next one starts on the 8th. There's no gap. But this one finishes on the 10th, and the next task starts on the 13th. There's a gap, right? There's a gap of 2 days, the 11th and the 12th. And during that time, we have a gap where task D could fall behind 2 days, and we'd be okay because this one isn't scheduled to start until the 13th. That's called free float. So while I've got 2 days across the top here, this one is actually a little bit special, right? These are just regular old float, but this one is free float, and free float is worth its weight in gold. That's the one that doesn't impact your project at all. You don't really have to take any kind of special measures when you use it, versus these other ones that would continually push the other activities behind. So on the exam, they may ask you to locate free float. Which of the following tasks has free float? And now you've got to calculate it out. You've got to figure out your early start and late start and your early finish and late finish so that you can spot where the gaps are in between the tasks, and that's where your free float is. And if you've got no gaps, you've got no free float. You may not, right? So it's important to note that.
Now, Don, it's a great example for us. It's a great reminder of some of the things that we may have forgotten along the way as we've been preparing for the exam. And it's something that we really need to pay attention to, being able to determine that overall critical path. A lot of times we take a look at these numbers and we get a little bit confused. Go back, watch this episode, make sure you do take a note of this example, work through the math, feel very comfortable with it. But we've got some more examples coming up. Don, any last words on just this first example here?
Just run through them. Maybe I'll show in another episode. If you have Microsoft Project, you can actually create diagrams like this in Microsoft Project, and you can create a project, work it out yourself, and then feed it all into Microsoft Project, and it kind of grades you. So you can create your own practice test for these things. But just get used to it. Run through them. Run forward, run backwards, check your work. It's easy to make mistakes, especially if we're not thinking of days. If we're thinking of numbers instead of days, it's easy to kind of screw things up there. So definitely be wary of that, and always double check your work, and just get to where you're proficient and fast at it.
Well, Don, thank you again for showing us that example. Thank you for joining us today. Signing off for IT Pro TV, I'm Ronnie Wong.
And I'm Don Pizzette.
And we'll see you next time.